Okay, Assalamualaikum warahmatullahi wabarakatuh. So for today we are going to continue on the topic of estimation. Okay, so previously you already learned on estimation for one population mean. Okay, so for now we will continue on the estimation, but for the difference between two population mean. Okay, so for today is specifically focus on when we have two population mean, okay, for independent sample. Okay, so actually there will be two type of sample. Okay, first we have independent sample and the other one we have dependent sample. Okay, so I will explain first what is independent sample. Okay, so 3.3.2 interval estimation for two population mean. Okay, so we will discuss estimation procedure for the difference between two population means. Okay, let's circle into the example first. Okay, we may want to find interval estimation on the difference between the mean length of insect measured by two different microscope. Okay, the other one, we may want to find the interval estimation on the difference between the mean pH in rainfall of two different areas. Okay, the procedure to compare the two population mean are based on the relationship between the two set of sample data taken from the respective population. Okay, so meaning that for example number 1, okay, so we have two different microscope. Okay, so we want to know is there any difference between the two microscope in terms of length of insects measured by these two microscope. Okay, example number 2, we want to look into the difference in the mean of pH, okay, of a rainfall for the two different area. Okay, so we have two population here in terms of area lah. So we have area 1 and area 2. Okay, we measured the pH for these two areas. So we want to know whether is there any difference in terms of mean. Okay, mean of the pH in rainfall for the two areas. Okay, so as I mentioned before, the relationship can be two types. So first we have independent sample or dependent sample. Okay, so the two examples given above are two different types of interval estimation for difference between two mean, independent and dependent sample. So what are the mean by sample are independent? Okay, so independent here mean when they are not related. Okay, for example, okay, independent sample, let's say we have population 1 is a male student, population 2 is female student. Okay, so what I measured from these two sample, let's say I want to see whether there is any differences in their CGPA. Okay, so I measure from male and I measure from the female. Okay, so clearly we can see that there are two groups of sample that are not related at all. Okay, but for independent sample, for the dependent sample, means that the sample when the subjects are paired or matched in some way. Okay, the data may be paired when the data are obtained from before and after studies, from pair of identical twins, or from matching two subjects of similar traits to form match pair. Okay, so untuk dependent pula, for dependent pula, beza dia adalah, okay, let's say data tu kita ambil from the before and after study. Okay, maksudnya okay, katakan saya ada pelajar AP yang mengambil subjek statistik. Okay, so I want to know whether is there any differences in their statistics score, okay, before that 10 one courses on a statistics subject. Okay, so meaning that I have one subject. Okay, subject here is AP students. Okay, so I measured their score in statistic course before they attend the statistic course. Okay, let's say I have 20 students. Okay, I give them one quiz. Okay, and I record their score. Okay, and then the following weeks they attend one statistic course. Okay, and they learn on statistics subject, and then after that I give them back the same quiz on statistic. Okay, and then I measured. So there are the score has been obtained before and after they attend the courses. So I want to know whether is there any difference in the score before and after they attend the statistic course. Okay, so meaning that for a dependent sample, okay, we measured certain population twice. Okay, 2 times. Okay, on the same subject we measure 2 times. Okay, ataupun katakan benda yang sama, okay, kita measure 2 kali, before and after. Okay, ataupun berat, katakan kita measure sebelum they take certain weight loss program. Okay, before, and then kita measure lagi sekali after they complete the weight loss challenge, katakan. Okay, so nak tengok ada beza tak sebelum weight loss challenge and after weight loss challenge. So that is mean by the dependent sample. Okay, so kalau independent memang clearly kita ada 2 group yang berbeza dan kita nak tengok ada beza tak di antara between the 2 groups. But the dependent pula, okay, dia ada data tu ada 2 group. Okay, tapi kita measure from the same population. Okay, ataupun from the same subject. So now we will look first into confidence interval for the difference between 2 population means. Okay, specifically for independent sample. Okay, so from the definition, the sample are independent if they are drawn from 2 different population and the element of one sample have no relationships to the element of the second sample. Okay, so meaning that clearly we have 2 distinguished groups, okay, that we measure, and then these 2 has no relation at all. That's why dia dipanggil independent, tidak berkait. Okay, for example, if we want to estimate the difference between the weight of male and female student, okay, we select 2 sample, one from male student population and another from female student population. Okay, so why we call these 2 sample are independent? Because they are chosen from 2 different population and the sample have no effect on each others. Okay, so kita ada population 1, and then we have population 2. Okay, so kita tahu mu untuk population 1, kita tahu mu untuk population 2. Okay, so apa yang kita nak tahu sekarang ni, ada beza tak antara population 1 and population 2? Okay, is there, adakah mu dia sama, mean population 1 dengan mean population 2 sama atau tidak? sama atau tak sama. So apa yang kita akan gunakan kat sini, then the x bar 1 minus x bar 2 is the sample statistic used to make the confidence interval. So the estimation when we have when we want to look into the difference between population 1 and population 2, the statistic that will be used here is kita akan based on the x bar 1 and x bar 2, meaning that sebab kita ambil daripada sampel. Okay, so that's why kita memang kita nak tahu adakah mean dia, mean population 1 and mean population 2 tu sama, tapi we does not measure every single item in each population, but we just take the sample. That's why the statistic used here is x bar 1 and x bar 2. Okay, so meaning that the information that we have here, kita ada value x bar 1 dengan x bar 2. Kenapa x bar? Sebab kita measure dia, just kita ambil sampel sahaja daripada population, bukannya kita measure every single things in the population, but we just take a portion from the population. That's why dia gunakan notation x bar. Okay, so kita nak tengok ada different tak. So from that we generalize on the population. Okay, so untuk the different the estimation for the difference between two population, we will have 4 case. Okay, so untuk for case number 1 adalah when population variance are known. Okay, sama ada variance ataupun standard deviation lah. So sigma 1 square, sigma 2 square ni adalah variance for both population are known. Okay, ataupun kalau dia tak bagi variance, dia bagi standard deviation. So ini dia bagi sigma. Okay, kita tahu population variance or population standard deviation for both population. So formula that will be used is x bar 1 minus x bar 2 plus minus z alpha over 2 times sigma 1 square over n1 plus sigma 2 square over n2 square root. Okay, so sebab kita tahu population variance ataupun population standard deviation, that's why kita akan gunakan z kat sini. Okay, itu case yang pertama. Second case, population variance or population standard deviation are unknown. Kita tak tahu, okay, maklumat population, but tapi n dia besar, both sample are greater or equals 30. So the formula is x bar 1 minus x bar 2 plus minus z alpha over 2 times s1 square over n1 plus s2 square over n2. Okay, so kalau awak tengok kat sini, dia still guna z. Okay, sebabnya n dia besar. Okay, tapi kita tak tahu dia punya population variance or population standard deviation unknown. Okay, that's why kat sini dia guna notation S. Okay, berbeza case nombor 1, dia guna sigma sebab dia punya variance or standard deviation unknown. Okay, kita akan guna Z. Untuk case yang kedua, kita akan guna Z juga, tapi sebabnya kita tak tahu, tapi kita guna Z sebab n kita besar, sampel kita besar, that's why dia guna Z. So the difference kat sini in term of this one lah, ini sigma, kat sini dia guna S. Okay, so kalau tersilap guna between case 1 and case 2, tak ada masalah, dia tak ada efek yang besar sebab dia still Z. Okay, cuma yang silap in term of formulation yang awak guna lah, tapi dari segi jawapan dia tak ada efek. Okay, so case number 1, population variance or standard deviation known. Okay, case number 2, population variance or population standard deviation are unknown, but sample size are large. Both are greater or equal 30. Case number 3, population variance. Okay, case number 3 dia unknown, tapi we need to assume that the variance are not equal, and the other one, dia kecil, N1 and N2 less than 30. So formula yang kita akan gunakan adalah X bar 1 minus X bar 2 plus minus T alpha over 2 degree of freedoms time S1 square over N1 plus S2 square over N2 square root. Okay, where the formula for degree of freedoms is S1 square over N1 plus S2 square over N2 square over S1 square over N1 squared over N1 minus 1 plus S2 squared over N2 square over N2 minus 1. Okay, so untuk case number 3, kita akan gunakan, kat sini dia dah start guna T. Kenapa T? Sebab ni, sebab sampel kita kecil, that's why kita akan gunakan T. Okay, untuk case number 1 and case number 2, kita akan gunakan dia Z. Okay, sebab apa tadi? First, sebab population variance or standard deviation unknown. That's why kena guna Z. Yang pertama. Case yang kedua, sebab N dia besar. Okay, cuma beza dia dekat kat sini lah. Okay. Untuk case number 3, dia dah start N kita kecil, less than 30. Okay, still kita tak tahu population variance and population standard deviation, but we assume the variance and the variance or standard deviation are not equal between the two population. Okay, so formula dia again, X bar 1 minus X bar 2 plus minus T alpha over 2 degree of freedoms. Okay, kat sini dia guna S sebab kita tak tahu kan, that's why symbol dia S. Okay, untuk case number 4, population variance are unknown. Okay, sama juga, still unknown. Okay, but we assume the variance are equal. Okay, case number 3 tadi not equal. Okay, yang ni kita assume dia equal, and still and a sample dia less than 30. Sample dia small. Okay, so again the formula X bar 1 minus X bar 2 plus minus T alpha over 2 N1 plus N2 minus 2, dia punya degree of freedoms. Okay, darab dengan pool standard deviation time 1 over N1 plus 1 over N2, yang mana formula SP dia adalah N1 minus 1 S1 squared plus N2 minus 1 S2 squared over N1 plus N2 minus 2, and don't forget to square root. Okay, so maksudnya kena cari pool standard deviation dahulu, masukkan ke dalam this formula. Okay, so kat sini boleh nampak dia gunakan T. Sebab apa? Sebabnya sampel kita kecil. So case number 1, case number 2 kita guna Z. Okay, case number 3 and case number 4 kita guna T. Sebab sampel kita small. Cuma beza case number 3, we assume variance are not equal. Case number 4, we assume variance are equal. Okay, so bertambahlah formula yang awak perlu ingat untuk topik estimation. Okay, so we will look case by case after this. Okay, we will look example for each cases. Okay, let's continue on population. Let's continue on case number 1. Okay, so case number 1, we have population variance unknown. Okay, so what are the assumption? Okay, the assumption are population are normally distributed. Okay, so the 1 minus alpha times 100% confident interval for mu1 minus mu2. Okay, which is the difference between population 1 and population 2 is X bar 1 minus X bar 2 plus minus Z alpha over 2 times sigma 1 square over N1 plus sigma 2 square over N2 square root. Okay, let's look into example 3.12. Let X and Y equal the amount of suspended particulate matter measured during a 24 hours period in a home in which there is no smoker and a home which there is a smoker. Assume that the distribution of X and Y are, okay, untuk X has normal distribution with mean X and variance 64, okay. And for Y, we has normal distribution with mean Y and variance 36, okay. A random sample of size 9 yielded X bar equals to 93 and X a sample standard deviation equals to 12.4, while random sample of size 11 yielded Y bar equals to 130 and sample standard deviation equals to 7.2. Construct a 95% confidence interval for the mean difference of amount of suspended particular matter. Okay, so kita ada X and Y. Okay, population kita sekarang ni adalah X and Y. Okay, X has normal distribution with mean mu X and population variance 64. Okay, so meaning that now kita tahu dia punya population variance. Okay, ni untuk X. Whereas for Y pula, dia normal with mean mu Y and population variance equals to 36. Okay, so sekarang ni kita tahu maklumat population punya variance. Okay, untuk X 64, untuk Y 36. Okay, so kita ada population X and population Y. Okay, dia punya variance, untuk X, okay, variance dia equals to 64. Variance untuk Y equals to 36. Okay, now we are taking a random sample of size 9 untuk population X. Okay, so kita dapat value X bar dia, X bar 1 equals to 93 dengan sample standard deviation equals to 12.4. Okay, figure out what are the information are given to you. Okay, untuk population Y pula, X bar dia, okay, we are taking a random sample of 11. Okay, and then kita measure dia punya mean. X bar dia kita dapat 130 and sample standard deviation equals to 7.2. Okay, apa yang kita nak cari? We want to construct 95% confidence interval for the mean difference of amount suspended particular matter. So we're going to use this formula: X bar 1 minus X bar 2 plus minus Z alpha over 2 times square root of sigma 1 square over N1 plus sigma 2 square over N2. Why we use this formula? Okay, because we know the population variance. Okay, kita tahu value population punya variance untuk X and Y. Kita dapat ada 64 and 36. That's why kita akan gunakan case number 1. Okay, dan menggunakan Z sebab we know the population variance. Okay, so we just substitute into the formula. So X bar 1 kita ada 93, X bar 2 130 plus minus Z alpha over 2. Okay, so how to find the value of alpha? Okay, soalan kata construct a 95% confident interval. So meaning that our alpha will be 100 minus 95, we have 5%. Okay, so meaning that 5% is 0.05. Okay, so meaning that alpha kita is 0.05 divided by 2. Okey. Kita kena darabkan dengan square root sigma 1 square, population variance. Kita tahu population variance value dia 964. So 64 over N1. N1 is population X, and dia kita ada 9 plus population 2, variance dia adalah 36 over 11. Okay, Y, awak jangan ambil value S ya. Okay, kenapa kita tak ambil value S? Sebab kita tahu kita ada value population punya variance. Kita akan gunakan that value lah. But if you do not know what are the population variance or population standard deviation, baru kita guna value S. Okay. So untuk Z alpha over 2, untuk this one, awak akan refer table number 4. So cari Z 0.05 bahagi 2 is Z 0.025. So from table number 4, awak akan dapat value dia 1.96. Okay. So 93 tolak 130, kita dapat we get negative 37 plus minus 1.96 times, okay, times 3.2224. 3.2224. Okay, finally the answer is, so finally we get the answer is negative 433.3159 ataupun 316, and the upper limit is negative 30.684. So don't forget to do the subtraction first, okay, baru awak buat plus sign. Okay, buat minus sign dahulu. Okay, so you will get the answer is negative 43.316 and negative 30.684. Okay, so these are the confidence interval for the difference between population X and Y. Okay, kalau awak nak buat 130 minus 93 pun tak ada masalah. Okay, jawapan awak nanti akan berbeza dari segi dia akan jadi terbalik lah. Kalau awak buat 130 tolak 93 tak ada masalah, Y tolak X tak ada masalah. So nanti kat sini dia akan jadi positif. Dan kat sini nanti kita akan dapat this one dia terbalik lah, 30.684 and 43.316. Okay, maksudnya interval ni, confidence interval ni adalah positif. Okay, yang ni kita dapat negatif. Kalau buat Y tolak X, kita akan dapat positif value. Okay, so make sure you do the minus sign first, baru plus sign. Okay, so the answer for example 3.12 is negative 43.316 and negative 30.684. So mesti buat kurungan ya, barulah dia menunjukkan confidence value, confidence interval value. Okay, now you want to look if sigma 1 square and sigma 2 square, okay, variance are not known, but both sample size are 30 or more, then we will use the following formula. Okay, so the 1 minus alpha 100% confidence interval for mu1 minus mu2 is x bar 1 minus x bar 2 plus minus z alpha over 2 time s1 square over n1 plus s2 square over n2 square root. Okay, so let's look into example 3.13. A company manufactures and packages soap powder in boxes. The supervisor wants to compare the field weight of package from the west and east lines. Okay, so population, the two population here referring to the packages from west and east line. Okay, the following statistics are obtained. So for east, we have sample size 30, x bar 2.066 and variance 0.02. Whereas for west line, we have 30 sample size, x bar 2.069 and the variance is 0.026. Okay, so we consider both are large because we have sample size 30, but we does not know the population variance. Okay, kita hanya ada maklumat variance untuk sampel sahaja. That's why kita akan gunakan this formula. Yang berubah adalah this one. Kalau tadi dia sigma, now dia menjadi S. Okay, so you need to construct a 95% confidence interval for the mean difference between west and east line. Assume the variance are not equal for the two population. Okay, so apa yang perlu kita buat adalah kita identify dahulu alpha dia berapa. Okay, alpha dia, since kita nak construct 95% confidence interval, so our alpha is 0.05 lah. Okay, so you need to find value for z 0.05 divided by 2, z 0.025. So you are referring table number 4. We get the value z 0.025 if is 1.96. Okay, so just substitute into the formula. X bar 1 is 2.066 minus x bar 2, 2.069 plus minus z alpha over 2 is 1.96 times variance untuk population 1 is 0.02 over 30 plus 0.026 over 30. Okay, finally we get the answer negative 0.0797 and 0.0737. So again, kalau awak nak buat west minus east pun boleh, tak ada masalah. Nak buat east tolak west boleh, tak ada masalah. Jawapan je nanti akan jadi just terbalik sahaja. So, what if the question asking you to interpret the interval that you have calculated? Okay, so look at this value. So we get the 95% confidence interval for the mean difference between west and east line is negative 0.0797 and 0.0737. Okay, so apa yang kita boleh calculate kat sini? Since the interval, okay, so we can write as, since the interval contain 0, okay, so we can say that since the interval contains 0, there is no difference between east and west line. Okay, since the interval contains 0 value, there is no difference between S and west line in terms of the weight of package from west and east lah. Okay, kalau awak tengok kat sini, okay, tengok value interval kita negatif 0.07, 0.0737. Okay, maksudnya kalau buat garis nombor, okay, kita dapat negatif 0.07 kat sini, 0.07 7. Kat tengah-tengah dia ada value kosong, betul tak? Dia lalu kosong. So maksudnya bila kita tolakkan east dengan west, kita dapat dia punya mean difference dia adalah kosong. Maksudnya tak ada beza. East tolak west, east tolak west, kita dapat value dia kosong, difference dia kosong. Maksudnya east sama dengan west lah. Maksudnya berat packages from east line dengan west line are equal, no difference. Sebab tu saya kata no difference between east and west line punya weight of packages. Okay, sebab interval kita lalu kosong. So kat sini saya dah simplify kan untuk how to interpret the interval value. Okay. Bila kita ni specifically untuk difference between two population ya. Okay, so awak tengok ya, kalau awak punya interval, dia punya sign dia plus plus, maksudnya positif lah. So kita boleh kata there is difference in the mean value between the two population. Okay, since the interval does not passing the true zero value. Contoh, okay, awak dapat value tu positif, upper limit dengan lower limit dengan upper limit dia value dia positif. Ataupun kalau nampak lagi buat garis nombor, dia lalu kosong ke tak? Okay, untuk contoh yang ni 5.998 dengan 10.231, kat tengah-tengah dia tak ada kosong, dia tak lalu kosong pun. That's why kita boleh kata there is difference between the two population, meaning that population A tolak B, kita dapat value dia positif, okay, greater than 0. Ataupun kita boleh kata juga mean population A is greater than mean population B. Okay, yang ni kalau awak dapat interval awak positif-positif, maksudnya value dia lah positif-positif. Okay, kalau awak dapat value dia negatif-negatif, contohnya negative 10.231 and negative 5.998. Okay, so kita boleh conclude there is difference in the mean value between the two population since the interval does not passing the true zero value. Okay, so maksudnya kalau plus plus dengan minus minus, maksudnya ada difference. There is difference between the two population. Okay, cumanya kalau plus plus, maksudnya population A tolak population B is greater than 0, ataupun population A greater than population B. But if you get negative negative, meaning that population A less than population B, dia punya mean. Okay. But if you get interval dia negative and positive value, contoh negative 10.321 and 5.998, sini negatif, sini positif. So apa yang kita boleh kata, there is no difference in the mean value between the two population since the interval passing through the zero value. Maksudnya mean population A are equal mean population B, no difference between A and B. Okay, senang je nak ingat. Buat, kalau tak nampak, buat garis nombor. Dia lalu kosong ke tak? Kalau dia lalu kosong, maksudnya no difference lah between A and B. Kalau dia tak lalu kosong, maksudnya dia ada difference. Tak lalu kosong sama ada dia plus plus or negatif negatif. Awak punya value confidence interval tu lah. Okay, make sure value confidence interval awak, okay, contoh A, B. Value A ni mesti lagi kecil dari value B. Okay, cara tulis tu kena betul. That's why yang plus minus sign tu awak kena solvekan minus sign dahulu baru plus, supaya awak dapat value. Ni kita panggil, yang ni kita panggil lower limit. Lower limit. This one upper limit. So value confidence interval awak, value yang lower limit ni mesti lagi kecil dari upper limit. Cara tulis tu mesti betul. Biasa student silap buat kat sini lah. Dia buat plus dahulu, baru negatif, baru tolak. Yang betul kena buat tolak dahulu baru tambah, baru dapat value lower limit less than upper limit. Okay.